Hello everyone, this is Murli Krishna. Today I'm going to talk about a paper on emotion-based Spotify music recommendation for runners. This system called as DJ Running. The authors of this paper are P. Alvarez and their team, and they have worked it from University of Zaragoza from Spain. So yeah, so yeah, basically, we all know runners love music. When we are jogging, we would like to listen music and stay calm or something like that. So because it keeps them motivated and focused and often improves their performance. But most of the music systems today only consider basic preferences. What's missing is that which emotion they are currently in and what they are feeling right now and what kind of songs they need. So similar to our project, this paper also works on the people emotions and suggests them a music. So this is where DJ running comes and it tries to fill the gap uh, from emotion to what song they need rather than just listening to songs in their album. So yeah, that's the basic setup of this DJ running. And the goal is simply speaking. It creates a system that adjusts music in real time based on how the runner feels, like what they are and what type of running they're doing, and it taps into the Spotify's ecosystem and adds machine learning emotion tags to songs and makes dynamic and context-aware choices. So, and then finally, it presents the user the song and it automatically generates the next song depends on the pace and the situation they are. I'll explain example to you in later on slides. So how it works, uh, the system takes several inputs like your profile, your mood and live environment data like weather, terrain, where are you, which location are you doing and how's the weather over there. And it will take all real-time information regarding that. And it pulls an emotion tag Spotify database to recommend songs that match or guide your emotion state regarding like using the data it took, like the live data it took. And it asks the feedback, like if user is interested, he can give the feedback and it will just redefine their uh, songs in the next upcoming song, something like that. Yeah. So yeah, this how the it works, and it basically uses this model, Russell's complex model. It's a 2D model. Mm, It 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 just considers some kind of variables and it divides emotions regarding the variables. So they have done a lot of work, I guess. So like to find which features are important. So they took like Valence and aerosol as their accesses for this project, and they applied, like they selected four emotions: happy, sad, angry, and relaxed. For happy, the Russell complex model gave like high valence and high arousal is happy, and sad means low valence and low arousal, angry, similar, and relaxed. So they divided the whole data into four genres, so they could suggest the song depends on the values it has and depends on the emotion it has. So it will just connect the emotion to the mm, values of the balance and arousal. So the bridge between emotion and the song is this model, Russell's complex model. So, each Spotify song is assigned to one of these quadrants using the ML-based emotion tagging. And, this is a mobile app, like, or DJ running mobile experience. So the mobile app is the runner's interface. You start by creating a profile, then before each session, you select your mode, like you should say, I'm happy or something like that. So, either manually using a cartoon-based mode picker or whether a wearable device. So you will just give the emotion, either you'll pick something or you can just uh, send it like what emotion you are in right now, or you can just play directly, like something like that. So you need to give an input emotion, and depending upon your situation and all, it will adapt the music for the second song, third song, and fourth song. So you can see, like, see, starts training with personalized Spotify music. So after it suggested one song, and how do you feel and all, depending on the uh, surrounding circumstances and all, it will just change the next song related to the first song you have selected and the first mood you have selected. So, and the feedback and everything helps it to, give good song, good simultaneous songs one after other. So yeah, architecture of the system is simple, like, under it's built as a cloud fog hybrid. Like heavy lifting is done in the cloud, but the recommendation engine runs near the user. Uh, because we need to minimize the delay time of the song. So yeah, because user can't wait for 1 minute for getting a song after one song is completed, because after each and every song, the system adapts itself to give better song next song. So depends on him and everything. It will try to give another song. So the system also integrates weather API, Spotify data, and the terrain info to personalize everything. Yeah. And how songs are annotated, like, see, the data set, like the Spotify track which they use, it has more than 60,000 popular songs, and they are stored and annotated locally. So yeah, they, as told you about the Russell's model. So using that model, they will divide all the songs into four different kind of emotions: happy, angry, sad, and relaxed, using the ML-based MER. So this avoids the need of for manual tagging and makes scaling easier. So how DJ Running picks songs? Like how does it pick from the whole album which it has divided before? So as I said before, like it uses that. Fast matching, using it uses Hanoi, prox nearest neighbors algorithm, and it inputs the user mood, location, training, context, everything like which we talked till now, what all data it needs, and it will filters the personal preferences, social similarity, like what you are listening in past, or what your reactions in the past. If you are a new user, it will just consider the data as new and it will work on from there. So from 50 matches, filters are applied, like say personal taste, social similarity, and all. And it will return the top three most fitting tracks depending on what the uh, what input it has. So this is what I have been talking about. Like there is some real training, real time example also. So this is about a mid-aged half marathoner. Like so the session is 15 minutes easy, like 1 minute fast, 1 minute jog, and 15 minutes easy. There. This is the person's plan. So, like during warm up, it will give happy songs, and during sprints, it gives like more aggressive songs. And if jogs pace gets up, look, so he'll feel tired, so it will give calm songs. If the runner starts to slow down, then sorry, it's the pace gets increased, it will give relaxed songs, and if the runner starts to slow down, then it will give the calm music. The music adapts depending upon how you are running, and it will suggest it similar to it. And this might not be the case for everyone, but this is an example which they have provided in the paper. So yeah. Mm. This is where they tested with this app on some triathletes. So yeah, mm, that they tested this with actual triathletes. In one session they used motivating music, and in other they used aggressive tracks. Runners clearly responded differently, so they captured the emotions of the runners, and they, like, it shows that music has a tangible impact on mood and performance when emotion is factored in. So, like, they got to know whether the app, like, the music is impacting their emotion or not, and they could clearly see that, these triathletes are impacted depending upon the music they listen. So yeah. Yeah, what makes this unique is like it is the first app to combine emotion, context, and Spotify. It uses that tagged Spotify songs via machine learning. It is fully functional mobile app with real-time streaming, and as I talked in before, like it uses cloud services plus fog computing. Uh, it also learns from the user feedback, as I told earlier. It will every time asks the user feedback, or if he interests only, he can give, or else it doesn't matter. Like it can directly ask the user the feedback, or it can just sense by how he's doing. Like if he's slowing down. So if we give good music and if he picks up the pace, then we can recognize that yeah, he likes it or something like that. So depending on the circumstances, we can get the feedback. And limitations in future work. The main limitation is the scale. It's tested on a small groups, and the emotion sensing from variables is still evolving. So for getting the feedback via emotion sensing. So there is a lot of development needs to be done in this sector. So, the feedback might not be accurate every time, but, at least we are taking feedback and we are improving they are improving their system. Sorry for that. They are improving their system. So it's a good thing to, look at. And it's also an important future work, I guess, because if the sensing part is very important, like if the emotion sensing gets better, then they could easily give better song to the a person, and it can impact their day, because most of the people starts their day with jogging, or some of them ends their day with the jogging. So this is a huge part of their journey. And if we can give a song, correct song by their emotion, then regardless of what's the situation or what they're doing, we can always get along with it, because like the project we are working on, we will give songs depending upon their emotion. So if the like emotion detecting sensors, or emotion detecting senses in ML are evolved very good, then we could give them good song and we can find their emotion easily. So yeah. And the future plans involves like improve context integration and scale it to larger user. Then only you can improve the system. That's the very, very big point. And to this, they need to publish the app on the Google Play. So they are trying. So why this paper matters to me and us is like this DJ running shows how emotion-aware music can impact real-world performances. As I told you earlier, it uses the Russell model to bridge the gap. So it bridges music psychology and machine learning and user context. So in this case, they used this Russell's complex. So we can find something similar to it. So this paper shows that we could bridge that music psychology from using machine learning. And it shows how emotion labels happy, sad, angry, relaxed can directly drive recommendation logic. So overall, this paper helps me a lot and helps us a lot, because if we can detect the emotion of a person, then I guess like 90% of job is done, because if you can say if he is angry or not, then you can react it accordingly. So what I'm simply saying is like now I am talking. So if you can know in what emotion I'm talking, like am I excited, or am I scared, or am I worried, like what I will speak next. So if you could get that emotion of the person which he is currently in, either we are trying to find it by the sentence he speaks. They tried it by, the real life scenarios which they are in on climate and all. So regardless of what, like in any manner, if we can find the thing, uh, how people react, or why people reacted like that, everything is related to the emotion they are in the current stage. So yeah, so like after seeing this paper, I even got a little bit more confidence that we could also detect the emotion, not accurately, but we could at least try to detect the emotion from the call, from the text he sends, using our BERT algorithm, which has been already used to detect the emotion from the person's sentences. So yeah, I am very happy to present this paper. So yeah, thank you. Have a good day.